All right, so I'd like to say that that I'm more prepared than just for today, but with the recent onset of days off, I don't even prepare anymore. I mean, let's be honest. I prepare for that day, because who knows if we're in school tomorrow? Really? I hope not. Who knows if we're in school tomorrow? So I did not have do not have a formative plan for tomorrow anyways. So if we are not at school, we won't be missing anything. But outside of the next, so I've got Wednesday planned already. Outside of that, it's all kind of I wanted to take a test on the 27th, but that's not going to happen now. So maybe we'll get to it by the 1st of March. I don't know. I really don't, because who knows what next week brings. It seems like every week they say Snowmageddon is upon us again, or it's going to be another cold snap, or who knows. So I will try and keep you as informed as I can. As of right now, I'm looking at maybe we might have, I don't know, I'd have to sit down and look. I know what we're doing through Wednesday, so that's where we're at. So here we go. 3x3 systems of equations today. Okay, so that's 3 equations, 3 variables. And remember, for every variable that we have to have an equation. So if we have 1 variable, we can have 1 equation. If we have 2 variables, we have to have 2 equations. We did that last week with graphing and substitution and elimination. Today, we're going to start 3 equations, 3 unknowns. Okay? Now, if I were to say, is a solution and making it up as I'm going along here. What would you do if I gave you that question? Is 4, 7 a solution to that system of equations? Yes or no? How do you know? Okay. It doesn't work. Works in one of them, right? Okay. If I put 4 in for x in this equation, I'd have 5 times 4 minus 10 times 7, and that does actually give me negative 50, right? Because that's 20 minus 70, which is negative 50. So it works in that equation. So it's a solution to that one equation. But up here, 3 times 4 plus 4 times 7, that's 12 plus 28 is 40, and 40 is not equal to negative 17. So it's not a solution to the system. Okay? It may be in one, but not the system as a whole. Okay? Fast forward to today. Now, instead of having, this is called right here, this is called an ordered pair. Okay? Because there's 2 numbers, and they're in a specific order. X is first, Y is second. Now, because we have 3 equations with 3 variables, now we have something called an ordered triple. So our answers today are going to be an ordered triple. X, Y, Z. is that ordered triple a solution to that system? How do we do it? Plug what in? 7's going to be x, 1's going to be y, negative 3 is going to be z. Okay, so we plug them in. Do that now. Tell me if that ordered triple is a solution to that system. So 2 times 7 plus 5 times 1 plus 3 times negative 3 equals 10. 2 times 7. 14. 14, or 5 times 1. 5. 3 times negative 3. Negative 9. 14 plus 5. 19 minus 9. 10. Is 10 equal to 10? Yeah. Am I done? Why not? You gotta check them out, because it could work in one of them, but not the other two. Okay? Or it could work in 2 of them, but not the third one. So I got to check them all. Okay? So then we've got 3 times 7 minus 1 plus 4 times negative 3, and that's got to be 8. 21 minus 1 minus 12, that's 20 minus 12, that's 8 equals 8. So that one checked out, that one checked out. And then we've got 5 times minus 2 times plus 7 times, and that's got to be 12. And so then this is 5 times 7, 2 times 1, and 7 times negative 3. So that's going to be 35 minus 2 minus 21. 35 minus 2 is 33. Minus 21 is 12. So this one checked out in all 3. So is that a solution? Yes. So that is a solution. Okay. So let's come up with a way to solve. So one of the ways that we can solve a system of 3x3s is using what's called substitution. Now we saw substitution last week. What was our first step last week in substitution when it was 2x2? 2 equations, 2 unknowns. First step for substitution. Find one variable, get it by itself out of one of the equations. Okay? We had 4 choices last week because we had 4 different variables. We had 2 x's and 2 y's. Now, I got 9 choices. Okay? But that's still our first step. We are going to pick a variable from one of the 3 equations, and we're going to solve for it. Again, I would solve for the easy one. Okay? If I'm looking at this particular system, in equation number 1, side note, I usually like to Roman numeralize my equations, okay, so that I know which equation I'm talking about. Okay? So in equation number 1, we could solve that one for, what would be the easy one to solve for in equation number 1? Y. Equation number 2, we could solve for Z. Equation number 3, we could solve for X. Okay? So, pick one, X, Y, or Z, and then that one will determine which one we solve for. Doesn't matter, I need a letter. X, Y, or Z. Y? Okay? So if I'm going to solve equation number 1 for Y then, correct? Okay? So step number 1 says, from equation number 1, I'm going to have Y equals 10 minus 3x plus 2z. Agree with that? Okay. Step number 2 now says that oops, I shouldn't say that. Step number 2 from before. What did we do last week in step number 2 then, in substitution? After we solved for a variable. We took that and did something with it. So we plugged it into last week it was our only other equation. This week we've got 2 other equations. So what we have to do is we have to substitute that back into both of the other 2 equations. Okay? So we took equation number 1 and solved it for y. So then I'm going to start with equation number 2. And that's going to be 6x minus 2 times what y is. Y is 10 minus 3x plus 2z. And then plus another z. And that's going to be negative 2. Now, right away, let's just work that. Let's just make that look nicer. So we're going to distribute in that negative 2. And that's going to give us 6x minus 20 plus 6x minus 4z plus z equals negative 2. That's going to simplify down to 12x minus 3z equals 18. Agree with that? Okay. Then I need to plug it into equation number 3. So that's going to be x plus 4 times 10 minus 3x plus 2z plus 3z equals 7. Again, distribute, distribute, and distribute. That gives me x plus 40 minus 12x plus 8z plus 3z equals 7. I got negative 11x plus 11z equals negative 33. Yes? Okay. And those 2 new equations that I've created, I'm going to label them as equation numbers 4 and 5. My next step now is I am going to use elimination or substitution on, oops, let me move that down a little bit, on those two new equations, and I'm going to solve for those two variables. Okay? What do you want to do? Elimination, substitution on equations 4 and 5. What are we thinking? Elimination? So I'd have to either multiply the top equation by 11 and the bottom equation by 12.
Or simplify the bottom equation?
Like, what do you mean?
Like divide by 11?
Like divide everything by 11 in that one?
Yeah.
Okay. Step number 3 now. So you're saying we're going to take equation number 5, and I'm going to say negative 11x plus 11z equals negative 33. And I'm going to make that be, can I divide by negative 11? Okay, because then that would be x minus z equals 3. If I divided every term by 11, by negative 11. Makes it a little bit easier, right? Okay. And then what would you multiply that new equation by? Negative 3. Okay. So my new equation then would be negative 3x plus 3z equals negative 9. 12x minus 3z equals 18. I get 9x equals 9. So then what? Divide by 9. So x is 1. Okay. Just remember that. We'll put it in bright yellow. Okay. So if x is 1, then I'm going to go back up here into equation number 5. And I'm going to say that negative 11 times 1 plus 11 times z has to be negative 33. Or I could have went into equation number 4 too. Negative 11 plus 11z equals negative 33. 11z equals negative 22. So z here is negative 2. Agree with that? Now what? Put both of those into an original equation. Oops. Whoops. Come on now. Come back down here for me. Okay. Come on now. There we go. Now we got it. Whoa, now we got shrinking. So step number 4 then is we're going to put those two variables, x is 1, z is 2, into, or z is negative 2, excuse me, into one of the original ones. And Antonio, which one did you want to choose? Number 1, because that's the easy one for y. Okay? So equation, or step number 4 here, equation number 1 again was 3 times x, and x is 1, plus y, minus 2z, and z was negative 2, and that's got to equal 10. So 3 times 1 is 3, plus y, negative 2 times negative 2 is 4, that's going to be 10. Y plus 7 is 10. So what's y? 3? Okay? So now what we have to do is our last step. Step number 5 says we got to check our work because we just did a lot of work. And it would suck if we did something wrong. We missed a negative sign somewhere along the way, right? Well, we can check it. Okay? Now, I've been saying it for 2 weeks. Check your work, check your work, check your work. Okay? Quizzes that we took on Friday should have been 20 out of 20s. Across the board. Because if you checked your work, you know if you're right or not. Okay? And everybody got done with plenty of time. If you're not right, go back and fix it. That's the whole point of the check. Okay? You should be getting 100% for this entire unit. Okay? So, let us go back and checketh our worketh. So equation number 1 was 3x plus y minus 2z equals 10. Okay? We think that x is 1, so that's going to be 3. We think that y is 3, so that's going to be 3. And we think that z is negative 2. Negative 2 times negative 2 is positive 4. So that's going to be 10 equals 10. That one checks out. Equation number 2 was 6x minus 2y plus z, and that's going to be equal to negative 2. X we said was 1, so that's going to be 6. Y we said was 3, that's going to be minus 6. Z we said was negative 2. 6 minus 6 is 0, minus 2 is negative 2 equals negative 2. Checks out in that one. Third equation, x plus 4y plus 3z has to be 7. X was 1, so that's 1. Y was 3, so that's plus 12. Z was negative 2, so that's minus 6. 1 plus 12 is 13, minus 6 is 7. 7 is equal to 7. So it checks out in all three. So our answer here is going to be 1, 3, negative 2. Written as an ordered triple. Okay? What I'd like you to do now is I would like you to solve this system of equations using substitution. Which equation, 1, 2, or 3, and which variable? 3 and y. Okay, easiest of all 9 of them. Okay, so we all should have gotten here 6x plus 4z plus 1 equals y. For step number 1. Yes? Okay. So then in step number 2, now we got to plug that back in. So 4x plus 2 times 6x plus 4z plus 1 plus 3z is equal to 1. So that's 4x plus 12x plus 8z plus 2 plus 3z is equal to 1. 16x plus 11z equals negative 1. Call that equation number 4. Then 2x minus 3 times 6x plus 4z plus 1 plus 5z equals negative 14. 2x minus 18x minus 12z minus 3 plus 5z is negative 14. We'll call this equation number 5. Negative 16x minus 7z equals negative 11. Yes? Okay. Equations 4 and 5, substitution or elimination, run on them. Elimination, it's already set up for us, isn't it? Okay. So 16x plus 11z equals negative 1. Negative 16x minus 7z equals negative 11. Add those two equations together. 4z equals negative 12. So z is negative 3. Agree? Okay. It really doesn't matter which one we go into, so let's go 16x plus 11 times negative 3 has got to be negative 1. So that's 16x minus 33 equals negative 1. 16x equals 32. X equals 2. Okay. Step number 4 says 6 times 2 minus y plus 4 times -3 has to be -1. 6 times 2 is 12 minus y. Oops. Minus 12 equals -1. So this is negative y, oops, equals -1. So I get y here is 1. Agree? Okay. So my suspected answer is 2, 1, -3. Right? Okay. So let's go back and check it. I don't think I can fit it in. No. Okay. So 2. I don't see any color that would actually be. Nah, we'll just do it that way. Okay. So x was 2, right? Yep. So that's here. This one's going to be 8, right? Plus 2y. Y was what? 1. 2, 1, -3. So then that's going to be plus 2 and then minus 9. 8 plus 2 is 10. Minus 9 is 1. Checks out there. 2 times 2 is 4. 3 times 1 is 3, so minus 3. 5 times -3 is -15. So 4 minus 3 is 1. Minus 15 is -14. Checks out there. 2 times 6 is 12, minus 1. 4 times -3 is -12. 12 minus 1 is 11. Minus 12 is -1. Boom. Checks out. Works out. All is well. There is our answer. Okay? What? Checks out, works out, all is well. It's good times. This homework will be due on Wednesday. And no formative tomorrow. Again, let those problems breathe.